All right, so I deburred the ends of these pins, and I'll dip them in some old whey lube here and see if we can get this pin to go in and stay and go home. Here we go. So yeah, that's nice and tight. It's not too tight, it's not wobbly, and it should guide the pin pretty good, or the ejector plate. I think I'm going to add these springs as well, which, you know, you string the spring coaxially onto your return pin slash slider guide pin, and this spring helps keep the plate kind of under control. The molding machine doesn't need this spring, but I'm going to put it in just to help keep the forces coaxial, so that this pin kind of remains coaxially square to the hole that it's trying to guide in, so that it doesn't start jamming up if the plate starts to get crooked. It just helps a little bit, but it won't return the plate. Well, maybe it will actually, we'll see. All right, so what I need to do is cut these pins or machine these pins to the correct height. And actually my machining fixture over there for the ejector pins will set this to the right height, but I think I'm going to cut some of this excess off the end of our pin here. So I'm going to mark it and then cut it with the die grinder. And then I'll machine this pin to size. Actually, I recently discovered that these pins are not super hard, so you can actually machine them with like a steel cutting end mill, which is nice. All right, I'm going to cut these and we'll be right back. Give it a little juice. And there we go. All right, here's our first return pin, which feels good. It may still be kind of a thousandths over, but that's all right. It'll kind of settle in. Usually when the mold clamps up, things settle in a few thousandths more anyway. We'll check our second return pin over here. That one feels good as well. Yeah, okay. So let's assemble our ejector plate. So I stick our return pin in its pocket there. Made it a little tight. Ouch. Of course, you get steel splinters when you machine these ejector pins, little tiny razor sharp shards. I'll oil our guide hole a little bit. So this is a steel on aluminum hole, and yeah, look at that, it actually lines up. That's good. Sometimes steel on aluminum isn't the greatest idea. But this is going to be a short cycle production mold, but that actually feels really smooth. Like I can push anywhere on this plate and the pins actually slide instead of pushing back out of its own ejector plate. So yeah, that's actually really good. I may not even need those the springs. Sometimes I'll add, like I mentioned, I add the springs here to help fix moment arms and torsion on the plate, but I'll probably still do that, you know, but that's really good motion. So, not to toot my own horn. All right, so let's stick all of our ejector pins in now, and like I mentioned before, all of these pins are the same height. But the shoulder is It's taller than the shoulder countersink in this mold because I wanted to maximize the reamed 1/16 holes at the front of the mold. But the plate isn't going to go this far forward anyway, because the pins would be beyond the part by an extra 10 millimeters or so. So I think we're fine. And these are the first time putting these pins in, so they are going to feel maybe a little bit of a burr from the back drilling as it enters into the reamed hole. And we're probably just pushing out a little micro ring of aluminum, which is no big deal. There's no like transition die mold insert like the the dual shot mold I was working on. So this is just straight up aluminum billet. So there's a few less things that can go wrong, but there's different things that can go wrong with aluminum billet. All right, so let's pull back our ejector plate a little bit so that all of our pins will seat into their pockets, like so. And then we can stick or bolt on our clamp plate behind there, which is right here. And M4 socket cap head screws will bolt on. And this pin can go in any time because the half 13 threaded rod for the molding machine is going to screw into the back of this ejector plate assembly to actually push and pull. So this is going to come out all the time. So it's almost an afterthought, but I do need to ream that hole. So I'll get some M5 screws. This is moving really smooth. So one thought is to stick the springs on. Maybe I'll do that since I have them. This may be a mistake, but I'm going to pull the ejector plate out and string our return springs on, which are not critical. Let's see if I can line everything back up. These holes are not chamfered. This may have been a mistake. Oh. Let's try it this way. Everything has to hit and be aligned simultaneously. If one pin is off, it prevents all the rest of it from dropping. So like this guy right there, and there's some pin in here that is hitting the sidewall there, I think. Sometimes you can give it a little convincing. Oh, we're going in crooked. There we go. Ah. Okay. There we go. Okay, now we got our return springs, and we can push that far forward. So that's good. Really good action. These springs really come into play after 5,000 cycles, when the plate starts to get a little wonky. Then these the forces out at the edges where the bearing is keeps everything controlled, so it's nice and happy there. Okay, so I'll finish putting our screws in. sometimes you got to take everything apart if what we just did didn't work out. So I figured I'd not put all the screws in. So the reason these bearings are working, because with especially no bearing liner, is that we have like maybe 5 rod diameters or shaft diameters in bearing length. So the shaft going into its hole doesn't have the opportunity to get cocked or off angle too much, or if the angle difference is extremely small because of the tight clearance of the shaft to the hole and the depth of the hole. If we had a hole that was 1 diameter of the shaft and we tried to have this be a linear bearing, it wouldn't work out because the shaft would rather just go crooked and jam up on the top and bottom edge and kind of gall up and then jam. But since we have a deep hole that's like 4+ diameters of the shaft, then that shaft has no other option but to be parallel and not concentrate stresses on friction at the leading edge of each end, because it's remaining parallel with the other shaft helping it remain parallel. So yeah, we get really good action that way, and it's nice and clean. But you do have to CNC these holes, and you know, everything's got to be CNC'd to within a few microns, which is easy for the mill. For this to work. All right, now we can finish assembling the B side of our mold. So these are the riser blocks with the machined out notch. So you can kind of see the clearance that we added using the shell mill. And I'm cleaning the surfaces so that we got no debris that's going to knock the squareness of our mold off. And then you can see that these springs doesn't quite return the plate to 0. There's a little bit of a like a 2 or 3 millimeter or 100 thousandths gap right there. So we're still going to have the molding machine pull this plate to the home position. Let's stick that guy on, and then I've got these bolts, which should be pre-made and ready to go. My brother actually makes these riser blocks and base plate for me. He's got a machine shop on the East Coast in his basement. I actually have an episode maybe a year and a half ago where I visited his machine shop. You should check it out. I can put a link in the description. And these threaded holes back here will thread into the molding machine platen. And similarly, we've got threaded holes on the A side, which will bolt onto the A side of the molding machine platen. So it makes loading this mold a little bit easier. Okay. So we've got return pins that are flush, and it looks like all the ejector pins are flush as well. So we are good to go on the B side of this mold. Of course, our spring is actually loose, or it's at 0 deflection right now, so that's all right. Oh, there we go. Yeah, that works. I may have a little bit of a rub right here, but I don't know. I think for first article we'll be good to try it out. I'll have to go back and see if I can relieve this bottom plate. It looks like maybe it didn't machine accurately enough. So anyway, all right, moving on to the A side. I think all I have to do with this one is add the steel inserts to basically engage with these return pins, these steel return pins. This is kind of a new experiment. I have a concern about return pins gouging into the aluminum, and then changing the actual return plate or the ejector plate position. So I've made a couple of thread inserts out of 5/8 high strength bolts, which I need to bolt in here and then probably surface grind off. So let me find those and we'll be right back. All right, here's my quasi homemade thread insert. 5/8 11 hard steel with a machined in screwdriver slot, or a ground in screwdriver slot. I'm going to drive these into the mold, tighten them as good as I can. I need 3 hands to do this. I want to tighten this in good because I don't want it to be a nice stable, like solid steel mount or reference for the return pin. There we go. So I'm going to do a little bit of kind of hand polishing work on some of these surfaces in this mold cavity prior to doing the bead blast that we're going to be doing. There is some micro text that's machined into this mold cavity itself, which may be muted by the bead blasting, so I'm trying to figure out what to do about that. I do have some tapes here that I can do a bead blast mask, which is basically just a bouncing surface where the beads will bounce back off instead of obscuring or marring the edges of this machined in text of the part, which basically says plus, minus, and out, whatever that means. So gotta try to not obscure that. The other thought is to bead blast it and then remachine that text onto the bead blast surface. But at the time it was kind of like, let's get the text in there and then figure it out. And now we're at the point where we got to figure that out. I do have a, where's my little, oh, I have this thing, which is kind of nice. It's a little micro sanding belt on a plastic holder. Oh, let me get the, yeah, so this thing I got on Amazon. I think someone in the US makes it because they actually put a patent on there, so they want to sell these. But it's also good just for kind of grabbing a Brillo edge to clean up any residual, like submicron tool step over marks in your mold. So I'm not actually using the sandpaper here, I'm just using it as like a nice handle to conform this brown, or not brown, but the whatever this color is, burnt umber Brillo into the cavities of this mold to clean up any tool radius issues, hopefully. The bead blast is pretty good at just obscuring all this, but I'm thinking about masking the text so the bead blast won't fix stuff that is masked. It needs to be kind of a, I think I'll go for a kind of a grain look as opposed to a full polish, because full polish is problematic. And the bottom of the text is actually full polish from the end mill, so having a grain above it will help make the actual text catch the light and reflect it into your eye so you can read what the text says, because you know the text is deeper in the mold cavity, which will make it a shiny positive surface in the part itself. I think some of these surfaces still had a little bit of a tool scallop on it. So I can try to sand some of that off too. So I'm going to be molding first article parts, and usually you find everything that's needs updated in the part, and then you load your mold back on the milling machine and then kind kind of fix your list of issues that the customer finds. So it's very unlikely this will be finished per se, but first review parts are going to go out. So that is the rush. There, I'm covering up the text area for an experiment on the surface finish. All right, so here is the masked surface for the bead blasting. Put this thicker like mounting tape in the area where I want to cover the text, and then I use this white masking tape just to mask everything else, especially the parting line. So the masking tape actually kind of cantilevers over ever so slightly so that we don't round off the parting line and get flash in our parts. So I'm going to bead blast this real quick, and then we can load this mold onto the molding machine. All right, so we're using 0.5 millimeter glass beads in this blasting tank, and we got the mold loaded in there. It's a little difficult to see because there's old baking soda remnants in these glass beads as well. And this isn't exactly the best blasting cabinet, but what are you going to do? So I'm going to go for a lighter finish, hopefully, and see what happens. Yeah, it looks pretty uniform actually. Not bad. Yeah, the beads really clean up all your little micro tool marks or your raster marks, your step over marks. I'll probably get the iPhone to show a better image. All right, so after we finished the bead blasting of the A side features of the mold, that was the finished side of the parts, I went and reassembled the mold similar to what you saw on the bench. And I loaded the mold into the 25-ton Boy injection molding machine with the green robot mounted to it. And I did get some footage of the first round of molding, but not a whole lot because there were some issues that I was concerned about, which came to light, which effectively was those wedges that we added to the A side to create the sharp corners and the shutoff surface for the cores on the B side to kind of basically wedge into and create the open profile on the back of these shrouds. That aluminum to aluminum junction, especially when they were not anodized or had a ceramic coating added to the aluminum, they basically started to jam up and wedge up and not really gall, but it looked like they were about to start to gall up as well. To the point where the molding machine actually, a few times, it locked in so hard, these four profiles into the shutoff surfaces, that it created a locking wedge. And the molding machine actually couldn't open the mold a few times. So I had to get in there with effectively like a big rubber mallet and start banging on the mold while the molding machine is trying to open, and then it finally opened. So that indicated to me that I had effectively created a Morris taper in the mold. And I kind of suspected that would be the issue. So what I wound up having to do is pull the mold back out of the machine, and I replaced the aluminum wedges. I drilled and machined those out with steel plates that are semi-hard or pretty hard steel plates. Effectively, I just used some old machinist parallels, cut those up and created some wear plates that I then wedged into the back of the those slotted keys that created the shutoff surfaces and a little bit of the profile of the part as well. So you can see some footage of me doing that. And that really helped a lot. I also opened up a little bit of the alignment ring on the A side so that the two mold halves could find their center, their happy spot together. I allowed some drift in the A side so that they kind of locked and self-centered and reduced the stress. And that was successful, and we were able to mold the rest of the parts. But you know, basically, when you're mold making and you got an idea in your head, and you have that little thought that this may not be quite right, you should listen to those thoughts, because otherwise you can get kind of tunnel visioned and focus on trying to get your original design to work, even though you know it's not going to work. So sometimes it's best to just stop, you know, when you start to suspect that maybe this isn't going to work out, reconsider, and then abandon your original idea and then switch it up with something that is going to be a little more practical. And I kind of retaught myself that with this process. You know, so you kind of not necessarily swallow your pride, but know when to stop and reassess and stay calm. No, it's missing the flat on it. It's got a ball in because its original thing is gone. It's a blind hole because my wedge is already in that one. So anyway, everything worked out with the second round, and you can see how there's some footage of the robot pulling parts. And yeah, we ran 10,000 of those parts and everything worked out. turtle. Just leave me alone.
He's hoping he's hidden.
Yeah. No one can see you.